नमस्कार बच्चों, आज मैं आपके लिए लेकर आई हूँ चैप्टर 4 एनसीईआरटी का, जिसका नाम है प्रिंसिपल ऑफ मैथमेटिकल इंडक्शन। तो सबसे पहले हम समझते हैं क्या है इसका मतलब। प्रिंसिपल का मतलब है एक ऐसा रूल जो कि एक पर्टिकुलर इसके लिए दिया जाता है, एंड मैथमेटिकल इज रिलेटेड टू मैथमेटिक्स। नाउ व्हाट इज द मीनिंग ऑफ इंडक्शन हियर? इंडक्शन हियर मीन्स the process which moves from particular to general, matlab anything which is specified and particular facts are there which can be proved through the method of induction. Now let's see what the rule says. Okay, so let's move to the next slide. Now I'm going to tell you about the principle. So at first the rule for this says that you are going to represent a particular statement by the symbol p bracket n. Here n denotes all set of natural numbers. Here we can say n belongs to n. So anything which is given, it is all defined for small n. So the first rule says let for n equal n, and then you can write any statement. The statement should be written with the column p n. It is to be written down like this. Now let's come to the rule. What does the rule says to us? The first rule says that for n equals to 1, p1 should be true. Okay. The second rule says for n equals to k, here k is positive integer, let pk be true. Now this statement is actually nothing but a hypothetical statement. What it is? It's a hypothetical statement. We are assuming it to be a true statement. Okay, and then using this statement for all n belongs to natural number and k being a positive integer, we'll prove that for n equals to k plus 1, pk plus 1 should also be true. So what does this mean? That these are the three rules which specifies that for a particular statement the principle is valid or not. Now what you have been given in this method, you will be given a set of questions in which you will be asked whether the particular statement is true or not. So how you are going to prove that this is a statement which is true or not? By using the three set of principles. Now once the principle, the first one is very like you can say for n equals to 1, if the statement is getting verified, then you only proceed for the second and third statement. If the statement itself is not verified for n equals to 1, then you should not move for the further solution of it. Okay, so let me take one example of this. So let us take the example. I am taking the example of the set of first n natural numbers, which is given by 1 plus 2 plus 3 plus 4. It is equal to n. Now you all know, using AP, what we know is it is equal to n plus 1 by 2. This is equal to this. Okay, now let's prove whether the given statement is true or not. So let's apply the rule. So we'll start with n equals to 1. So let us put n equals to 1. So let's see what comes. So when we put n equals to 1, here the LHS will get the value 1. Here you are supposed to put 1 here is equal to, now let us put the 1 n equal to 1 in RHS. So this comes out to be 1 plus 1 upon 2. This will give you 1 equals to 2 upon 2, that is 1. So we can say LHS and RHS are same. So P1 is true. Similarly, let's move for now. What comes the next? It comes the hypothetical statement. What we have to see, that the hypothetical statement, it says that when we are putting n equals to k, then pk should be true. We are assuming it to be a true statement. So let us substitute n equals to k in this statement, which gives us 1 plus 2 plus 3. So wherever there is n, you put k is equal to k plus 1 upon 2. Now let this statement be a true statement. Now what we have to do is, we have to assume that we have to carefully watch the series given to us. Now this is an arithmetic progression, you all must have studied in your 10th standard. इस AP में आपको क्या दिखता है कि every term in this series, this is the observation which you have to do, because we have to make use of this statement to prove the next statement. So in every term is increasing by 1. So what will be the next term after k? It will be k plus 1, since every term is increasing by 1. So here also what we are going to do, please see to it, the next step would be adding k plus 1 both the sides. So what do we have now? Next would be that we are going to add k plus 1 both the sides. So what will come? Let us see. The LHS will be 1 plus 2 plus 3 plus dot dot dot. This will get k plus this will become k plus 1, and the right hand side will get the value k plus 1 upon 2 plus k plus 1. Now children, please see that the LHS is something we are already we are getting it already. So what we need to do is we have to solve the RHS part only, okay? Because we have to prove that in place of n, if we are getting k plus 1 also, then the statement gets verified, okay? So let the RHS and the LHS should be like this only. So let us write the LHS as it is, right? This is Pn. Now let us solve the RHS. Please see that in this k plus 1 is common. So I am taking k plus 1 common. Inside it will be k by 2 plus 1. So now what we are going to do, we are going to take the LCM here. 2 will be the LCM, and this will become k plus 2 upon 2. Or in general I must say this k plus 1, this k plus 2 I am splitting it as k plus 1 upon 2. Now here we see that both the statements here it is coming out like this only. Or you can say this is 1 plus 2 plus 3 plus k plus 1. This is equal to k plus 1 plus 1 upon 2. Now looking into the actual statement, what do we see? That this is n plus 1 over 2. It is replaced with k plus 1 plus 1 upon 2. So we can say that the statement is valid for p k plus 1 also, okay? So I hope you have understood this question, okay? Now let us see what the 1 mark question comes for this type of chapter. Like this is this type of question comes for 4 marks or 6 marks, and the higher level question can also come. So let us see what 1 mark question can come for this sort of PMI, using PMI, how you can prove this. So let's start with solving 1 mark question. So the question says, using PMI, that is principle of mathematical induction, show that n plus 1, n plus 2 is divisible by 60. Okay, this is divisible by 60, or you can say show that this is divisible by 60. This is one thing, or you can say instead of show them, आपको एक भी पूछा जा सकता है that find the value of P3. Okay, if n plus 1, n plus 2 is divisible by 60, find P3, right? So what we are going to do, let us write it like this: n plus 1, this is n plus 2. Now I am substituting n equals to 3 in this. This will give you P3 colon. What you have to do, you have to put n equals to 3 in the given statement. Okay, so let us see what it comes out to be. 3 into 4 into 5. This will give you what? 4 3 times 12, 12 5 times 60. Now this is coming out to be 60. Now 60 is divisible by 60. We all know this. So the statement gets verified. So this is the answer. Now such questions can come for 1 mark. Okay, this can come for show that also. This can come for finding also. This question will come for 1 mark. I hope it is clear with everyone, and now you have understood it, that how using PMI you can solve the questions very easily. Okay, so goodbye for now.